We are going to discuss about fifth model, start session, that is useful modeling techniques. Under this, we are going to discuss about useful system tasks. In this, we are going to study about the file output, displaying hierarchy, strobing, random number generation, memory initialization, value change, dump. See, in this today in this session, we're going to tell about file output, displaying hierarchy, and strobing. So how it is working, that is we're going to see here. See, file output. For this, we're going to use a is file output is nothing but opening a file. To open a file, we need to use one system task, that is a F open. The usage of this one is like this dollar f open under the double quotes we're going to say that name of the file with the extension name dot extension of the file f open. This will be return a value of f open is going to return a value of 32 bits uh, file descriptor we're going to say, that is multi-channel descriptor, you say, that is assigned to a value, that is file handle. This is a integer file handle, is nothing but an integer value, and the dollar f open with the double quotes we are telling that name of the file with the extension. See, this will be explaining how it is going to work and all. See here, fopen is going to give you the value of 32 bit called multi-channel descriptor. It returns a 32-bit value called multi-channel descriptor, and it is first bit. Only one bit is set in a multi-channel descriptor at a time. It is going to sets only one bit, and standard output as a multi-channel descriptor with the LSB bit 0. Standard output is called channel 0. Standard output is called channel 0, and standard output is always open. That is uh, this channel 0 is going to be open, and successful call, and each successful call uh, is of this F open opens a new channel and returns a 32-bit descriptor with the bit 1 set and bit 2 set and so on. If up to 30 bits it is going to sets and returns a uh, one bit at a time. That means one bit is going to sets and it will return that. And last bit MSB bit is going to be reserved. That is MSB bit is reserved here. And next, the example I will explain that. Here file descriptor how it is working. Here multi-channel in this we are going to take it with the example of three file handle. So we are going to use that is integers 32-bit values, and default the standard output is open, that is 32-bit hexadecimal here. 32-bit hexadecimal value it is given, that is bit 0 is set here, that is we are not considering. And when you use initial we can handle one f open file one dot out, that handle one it is going to have a bit one is set, bit one is set, and when you give the handle to f open, that successive calling of this f open dollar f open, it is going to gives that dollar file open, or we can say that is the successive bit of that second bit next to that it is going to 100, that is fourth bit it is going to sets, and here 1000, so for eighth bit channel it is going to give that handle 3 it is have a returning value of this 32 bit hexadecimal 8 bit 3 is set. So like this, the file multi-channel descriptor it is going to give you that when you use a successive yeah, file open tasks, when you give it will opens like this. So this is about file webhook one, and we're going to use another task, that is to writing to the files. whatever the file it is open, we need to write something onto that, or some tasks, or some programs we need to write. Means we will going to use a system tasks. That is, by using this system tasks, we are going to use writing onto the files. That is $f display, $f monitor, $f write, $f stroke are the used to write to the files. And here we are considering $display, f display, and $f monitor. F is whenever we are using file handling, we need to use this F for all the tasks. F is we're going to use for the file handling task, system tasks. For that, we're going to use a dollar. Dollar mentions that it is a system task. F is, it shows you that it is a file handling we are doing. Okay. In this $f display, the syntax for this $f display and file descriptor. What file handle one, handle two we are used in F open, file open task. That the same thing we are going to use here. We are going to use here. And P1, P2 are the variables, are signals, are quoted strings. We are going to use here. That is the file descriptors. And here $f open, F monitor is also, it is a file descriptor syntax. $f monitor with a file descriptor. When you give with a parenthesis or a circular bracket, when you use, then it is going to give you that returns a value, that is writing on the file, which file we need to write, that will be sense. And here what are the variables or some signals names you want to write onto the file, then that and that we're going to use here. Or quoted strings also. See here, writing to the file. Here integer, descriptor 1, descriptor 2, like this 3 file descriptors we are initialized, that is integer type. And initial begin, descriptor 1 is equal to handle 1 or 1. Handle 1 or, it is a bitwise descriptor, 1 or 1 we are taken, handle 1 or 1. So it is going to give that returns a value of 32-bit third channel it is going to opens and assigns to this descriptor. And then the display $f display, descriptor 1, display 1, write to files, file 1 dot out. That means file 1 dot out, it will going to writes onto the file 1 dot out and std out also. Here dot 1 handle 1 or 1 we are used. So it will display that is writing onto the file 1 dot out and std out also. That means channel 0 also. Channel 0 and file 1 also it is going to write onto this display 1. What is the string we are given. Okay. Next, the continuation of that same program. Here, descriptor 2, handle 1 or handle 2 or handle 1 we are taken. So it is gives you returns a value of 6. So 110 it is now. So it display the value, that means display 2, it is writing onto the descriptor 2, file 1 dot out and file 2 dot out also. So here 6 is here, 110. This is the equivalent to 110. So it is writing the display 2 is a string on descriptor, that is file 1 dot out and file 2 dot out. And when you use descriptor 3, handle 3, so it will write onto the 8th, that means 8th channel, that means file 3 dot out only. It will writes to the file 3 dot out only, right? Okay, that is about this is about writing to the files. Next we'll go and discuss about the closing file. So after opening we need to write something onto that, means we'll go to say dollar f display, f monitor, f strobe, all those things we're going to use. As it is after completing that, we need to close that file. Or if it is open only, then it will be something else. It is going to store on that. So for that, we need to close that file. For this, we're going to use a system task called fclose. $fclose. We're going to use to close that file. Okay, usage of this one is given here like this. Fclose with the file handle. See here, dollar. A file cannot be written to once it is closed. That means once if it is closed, we cannot write something you wanted to write onto that. Then we cannot go write one. And suppose you need to write something to this file, we need to use a F open. Once again, we can write it and then you can close. Like that, we have to repeat. Once it is closed, we cannot write onto this. The corresponding bit in the multi-channel descriptor is set to 0. Whichever the file you have closed, that will be closed. That means when you use fclose. So next fopen can use the bit. That means once it is open means that bit will be set. When you close that bit will be set to 0, so that we can use again when you wanted to open when you are used, that bit can be reused. So like this close file is also working. We are shown. Okay, next we'll go to the system hierarchy. That means is displaying hierarchy. How to display hierarchy? All of you know that how to display that hierarchy, and we have discussed in the previous model also. That means second model. I think the second model we have discussed. That is when you use a percentage m, this format specifier, it will option. It will give that whichever the system, top model it is working, that will displace that. Okay, see here with the example I'm going to explain. That is here. Hierarchy at any level can be displayed by means of percentage option in any of the system display tasks. That means any of the display tasks can be by can use percentage. That is module M is your main model, and here we are displaying that displaying in percentage. That means which model it is hierarchy it is working, that we can use here. And in that means in the stimulus or in the top model we are going to use model M, that is instantiation of that M1 instance, M2 instance, M3 instance. We have taken instantiation here and end model. See what is the output of this one, this program. Here it is going to display first M1 is the top model. So it displays top dot M1 is the hierarchy it is having. Then next hierarchy it is top dot M2, top dot M3. Like this it is gives you the hierarchy of that displaying hierarchy information. So for that that means here we came to know that percentage is a format specifier to display the hierarchy of the model, which hierarchy is having. Okay, next we'll go to this strobing. Here strobing is done with the system task dollar f strobe. Dollar strobe we're going to use to for the strobing. What is that strobing it is doing? It is nothing but a how what display task is doing. The same thing it is going to do, but a difference is slightly a small difference is there. It is similar to the task dollar display task, except for a slight difference. If many other system statements are executed in the same time, uh, same unit of time, then as the dollar display task. The order in which the statements and the dollar display tasks are executed is non-deterministic. Yes. So when you use that the same thing how the dollar display is working. The same manner dollar strobing is also done. But what is the difference is that in this dollar display, it is non-deterministic. It is not going to synchronize that execution. It will, whenever the dollar display comes, it will display on the monitor and executes like that. But here, stroke, when it's used, it is always executed after all other assignments, statements in the same time unit have executed. That is only the difference. It will executes after all other assignments statements in the same time is unit have executed. The dollar stroke provides a synchronization mechanism to ensure that data is displayed only after all other assignment statements which change the data in that time step have executed. Okay. That means the dollar stroke provides a synchronization mechanism to ensure that data is displayed only after all other assignment statements which change the data in that time step have executed. Okay, this is explained with an example how the strobing is going to work. See here, when you use strobing, here we have taken a always at posits of clock A is equal to B and C is equal to D. That means whenever the posit comes, it will assign a value of B to the A and D to C. See here it displays stroke, dollar stroke we are used here. Display A value and C value. It display at the posits of the clock. Then whenever the part comes, displays the value of this. But when you use dollar display, it will whether it is assigned or not. When you use here dollar display, displays the value of B and C because it is a concurrent operation. Always at posits of clock and always at posits of clock. These two statements are concurrent in nature. In Verilog, it is concurrent. So what it is doing, whether it is assigned or not, it will be displaying. But when you use stroke, it will assign the value of B to A and D to C. Then afterwards only it is going to display this A value and C value on the display. Okay, this is about strobing. Okay, this is your what is third session, and here these are the our team for Verilog HDL. We are done all with this example. Okay, thank you.